Sorry for the lack of downtime between both presentations. Maybe some people will just come in throughout the presentation. Next presenter, Elise Duchesne. She's an associate professor. She graduated in 2006 in physiotherapy at Laval University. Her research then got her into a master's degree in endocrinology in Laval University in 2008. Then she right away studies a doctorate degree in the same program, which she completes in 2012. Her thesis is on the contribution of mastocytes and the repair and identification of alternative mechanisms contributing to accumulation of macrophages. In 2012, she is appointed as the associate professor in UQAC, Université du Québec in Chicoutimi. Since then, she works on that new program and is the current temporary director from 2013 to 2014 and until from 2015 to 2016. She started a research program as an autonomous research independent researcher. She's still interested about skeletal muscles linked with genetic diseases located in Saguenay-Lac-Saint-Jean area, including DM1 and recessive autospastic disease. She's also part of a research group where she brings her importance to fundamental research. That group is studying neuromuscular diseases. So welcome, you have the floor. Good morning. Thank you for giving me this opportunity to introduce my research. As during the first presentation, you've seen the kind of work that we are doing. Marie-Pierre is my doctorate student. We are trying to develop a new research field to understand the missing box between the DM1 missing problems in the clinical evidence we see from these patients. As you have heard, I'm a professor at UQAC and also a member of the interdisciplinary research group in Saguenay-Lac-Saint-Jean. Title of my presentation: the effect of biological sex on the muscular deficiencies observed with people with DM1. There will be about 25 minutes of presentations and then a few questions. First, DM1 as part of a heterogenetic context. You know all the symptoms, so we won't go through them all. We will really look into muscular deficiencies and the concept of heterogeneity. Then, inspired by my colleague who has catchphrases, we'll talk about biological sex in DM1. I'll show also preliminary data we've collected in lab with regard to men and women differences, and a conclusion. DM1 and heterogeneity. In a few words, you all know that it's a hereditary disease, slow progression. This is a challenge because it's progressing slowly, and clinically we can see that people in here talking about from the muscle perspective, people are losing their capacity, but it's very hard to measure this loss because it is done on such a long time. Also, it's the most frequent adult myopathy, and in Saguenay-Lac-Saint-Jean is the area where there are the most people affected by this. In the world, it's about 1 out of 10,000 or 8,000, depending on sources. In Saguenay-Lac-Saint-Jean, 1 out of 500, 16 times higher in Saguenay-Lac-Saint-Jean area. There are 4 to 5 phenotypes, depending on authors. There's no official nomenclatures, so it's very hard to know the right number of phenotypes. What I'm saying that we are interested in Not saying that we have an interest, but our work deals with late and adult phenotypes for several reasons. This constitutes the largest customer base that we see at the neuro clinic in Saguenay-Lac-Saint-Jean, and ethically, it is much easier to also undertake such research to get their consent rather than to look into congenital or children phenotypes. As you know, below these deficiencies, beyond this, it has a lot of problems, create lots of problems, social participation, work problems, entertainment, and also travel problems. The phenotype varies a lot between individuals, and this adds a layer of complexity to this disease. For one same disease, maybe 5 people could have DM1, but these people will have very different profiles with a very different phenotype. Here's a few deficiencies that are multisystemic. Several systems are affected: heart, pulmonary, endocrine, visual, central nervous, and musculoskeletal. If we talk about signs, clinical signs, myotony, the most striking one rather. We see also muscular atrophy, smaller muscles, and also muscular weakness, a loss of physical muscle strength. We have submitted a paper on a 9-year longitudinal study. We looked into muscle strength, how it evolves through time for men and women, for adult and late phenotypes. And we see there's a muscular loss from 24 to 56%, and the difference comes from the different muscle groups that were tested, and depending on the muscle groups, it is more or less severe. If there was an average per year, which we cannot do because I don't know if that it is a linear loss, maybe because between 1 and 2 there's a lot of loss, but if we make it simple, which is quite hard in DM1, but still, if we can attempt to, the loss is about 3 to 7% per year in terms of muscle strength, which is quite significant for functioning. Here's some kind of framework that I've tried to draw between the clinical signs and what we see fundamentally. Marie-Pierre told you about a few concepts that I will also talk about, but I'll try not to repeat all of those. When we take all of these together, I've tried to do this exercise and also share how I imagine all of these elements. First, muscle weakness, which is the number 1 symptom in DM1. It limits social participation, and you clearly can see that. When we look at what causes this, it is muscular atrophy, which is meaning if we have a smaller muscle, of course, there is fewer contracting proteins that can create muscle strength, so this atrophy is causing muscular weakness. But there's something else also. We're talking about histology. Histology is when you look into a muscle, make a cut, and see what it looks like under a microscope. We're talking about the histology, and we look at muscle fibers that are atrophied. And the makeup of that muscle, there will be conjunctive tissues and also fat tissues. We all have a bit of both, but DM1 patients have more of these tissues. and doing so, there's less room for connective tissues. And this creates a striking muscle weakness for DM1 populations. Also, some authors have shown that there's a myogenesis, altered myogenesis. The fetus, well, that process creates muscles and is still present in adulthood, and muscles can repair because every day our muscles break down and are then recreated, and when we also train, there's a better synthesis. All this is normal, but in DM1, that process is altered, meaning that the muscle breaks down but cannot recover as well as a healthy adult. This altered myogenesis will influence balance. There'll be a unbalanced synthesis and protein synthesis and breakdown. This altered myogenesis and unbalance will affect muscle histology. This is the conceptual framework here. We can link all the elements from literature together. The fundamental study of the muscle can then explain what we clinically observed. I will go back to this slide. Now, with regard to the protein synthesis and breakdown and histology, these were the variables that we studied. And you've seen this chart earlier this morning. AKT and mTORs are actors of protein synthesis. These are all actors that are taking part in protein synthesis. We studied precisely those that are circled. And on the left, atrogen 1 and MERF. Names are not very important. I will always say if it's a synthesis or breakdown actor, and we see how there can be sexual differences or gender differences between these two variables. With regard to muscular histology, what we looked into is the transversal surface section. Muscular fibers are different. There are two types. Some that are more for power, type 2, and others more stamina based, type 1. There's one way to also color these differently through software. We can also measure the size of fibers following training. For example, when we say that the muscle is growing, it is individual fibers that are collectively create a bigger muscle. Particularly if there's a difference between sexes. Fibrotic infiltration, which I mentioned was not normal in the unhealthy muscle, and also fat infiltration. These are histological data that can help us measuring the quality of muscles. And what is the relevance of this for DM1? This was a chart for a grant that I included, but I thought it was very interesting to talk about this one here. What we know is that there's a genetic defect linked to irregular CTG repetitions. We know this gene. We know that there are transcription defects. Moving to the other side completely, we know that there's strength and functioning problems, which negatively influences social participation. This is clear in literature. What is unclear is this part in red. This is what I call the secondary measures. Under the big hat of fundamental indicators, there are primary measures with clinical indicators. Research is starting to be stronger and stronger, but there are also secondary measures. part of fundamental indicators, but that we disregard in DM1. Synthesis and breakdown, protein synthesis and breakdown pathways, myogenic processes. We all won't talk about them all, but you can understand what this black box is made up of. Now, the effect of biological sex. I read this article last week. Millions for precision medicine in Quebec. It said that 4 group of researchers not working on DM1, rather cancer, I think 2 groups on cancers, and what it said is that genetic precision medicine was the future for treatment. The broader message is that for the same disease, well, cancer is very heterogeneous also, and overall treatment cannot just be applied to everyone. We need to read a person's genetic, and depending on the genetic, give the optimal treatment to optimize chances of success. When we are finding millions of dollars for 4 research teams, they now have big means, and I think we believe in this principle at what it means. In DM1, it's quite the same. We cannot expect to have a silver bullet or the miracle pill, or no. So this is the concept here about precision medicine that I wanted to talk about this morning. Here on IRSA, Canadian Health Research Institutes. It's a big institute that is funding research everywhere in Canada. In the last 2 or 3 years, maybe starting from 2015, they really want to integrate sex and gender to research. Sex and gender, with all these news, there's a difference to make. While sex is biological, meaning a woman having 2 X, man, or X and Y, gender is how a person feels about it. I can have 2 X's but feel like a man. They make that difference, and they want as much as possible to integrate differences between men and women for one same disease. You can see that money has been invested for precision medicine with regard to genetic code. But before we get there in DM1, can we at least try to see if there are differences in men and women? Yes, it is not quite precision medicine. We separate men and women. Data I will be presenting to you deals with that. What are the histological differences and protein differences with regard to men and women? An article was published by Duchesne and partners in 2016. What this research shows is different signs here that are really proper to DM1. For example, mechanical ventilation, severe myotonia, different signs for all systems, and we can see if these are more present for a woman or a man. Without getting into too much details, what we can see is that there are differences between men and women. Meaning DM1 men have a different clinical picture from women in DM1. That's what we see. Now, if we look at this with regard to deficiencies, muscle deficiencies, here this introduces muscular strength over 9 years, the longitudinal studies I was referring to earlier. And we can see that it has differences between men and women. I will introduce these 4 charts: muscle strength progression from lower body muscles, without getting too specific details. The dotted full is women, and in black is men. So we can see for lower body muscle, time 1, time 2, there's a loss of strength, muscle strength for both men and women. we can see two things from this. This trend is true, except for hip muscles that we have problems with this. We'll talk about this later. Well, actually, we forget about it. We'll look at the other ones. And we see here that it is the same trend. Two things we can observe. Men are stronger than women. Wow, big news. Big news. We knew this already, but let's look at how muscle loss progresses between men and women. For men, we can see that there's a curve, a more important curve for men than women, and it is true in all of these. Meaning that on over 9 years, men stay stronger, but because they were stronger at the start, but they lost. Okay, I think I made a mistake here. Men stay stronger, but lost more strength than women. Women seem to be more protected against this loss of muscular strength, and we don't have all of the answers, but it shows that the stronger you are at the beginning, the more likely you will lose strength because you have something rather just to lose. If women at time 1 are not very strong, over 9 years they will not lose as much, while stronger men will tend to lose more. So clinically, we can collect these data, also publish this, but we don't know with regard to muscle integrity what is going on. These are my preliminary data, looking into if there are significant differences between men and women, and how certain key agents of synthesis breakdown are happening, so we can look if there are significant differences. We are trying to answer with secondary measures. We look into the profiles of 12 men and 10 women. We used a muscular biopsy mentioned by Marie-Pierre. It's a sample in the vast lateral muscle. We looked into breakdown indicators, protein breakdown indicators, AKT and mTOR over ratios, so P AKT over AKT and P mTOR over mTOR, and also this for synthesis, and also some indicators for protein breakdown, MRF and atrogene 1. The transversal cut area of type 1 and type 2 and the proportion of them. We looked also at the proportion of ratio of collagen area and fibrotic area. Here, with regard to protein synthesis, men were equal to 1, and we saw how women behaved. What we see is that there is a difference, significant difference, between men and women. Women seem to show fewer protein synthesis actors, phospho-AKT over AKT, compared with men. For mTOR, the other one, we said there is a difference, but it is not significant. There is a trend that is non-significant, however. Let's keep in mind these are indicators of protein synthesis. So with 1 indicators, there seems to be less protein synthesis for women. If we look at degradation, atrogen and MRF1, we see that I'd like to remind that men equal 1 here. Atrogen seems to be more present for women versus men. It is not insignificant, but for MRF, the second indicator of protein breakdown, we see that a significant difference. Some women seem to do less synthesis and more breakdown compared to men.
What about the histology? This means that we take the muscle, right? We do a cross-section and we look under the microscope what the muscle looks like. CSA is for cross-sectional area. This is a section, so it's more or less the size of a muscular fibers. We look into the fibers type 1 Arabic, and type 2, the muscular strength fibers. Here, in the blue, men, red are women. These are the values in square millimeters as the size, really the size of each fiber. So type 1 fibers for women are smaller, and type 2 smaller. Well, that's not a big surprise. It's normal to have a difference here. Now the proportion of fiber types seems to have less type 1 in women and more type 2 in women compared to men. What is the influence of this on the function? It is not clear yet. We have to correlate with other indicators to understand well. Now, the various other elements out from the contractile elements present in muscle, the presence of collagen, which is an indicator of fibrosis, and lipid. There's no significant difference between men and women for these two indicators. It doesn't seem to be a more important contamination between men and women as far as the fibrosis or fat infiltration. But when we do muscular biopsies, you could bring a sample. I could tell you, oh, that's a man, that's a woman. It is different. It doesn't look the same when we have that sample. These indicators we looked at, there are many others who want to look at capillarization. The fibers of men are more red than women. There's something, we don't know yet what it is, but indicators we chose maybe are not the right ones to check that, but we will push further. In conclusion, men have CSA that are significantly smaller than men for the two type of fibers, which is 1 and 2, and that is not a big surprise. These are the differences we would see in healthy patients. Proteomic, which are the synthesis and breakdown signs, are influenced by the, I said gender, that's an error, is by sex. Since the ratio P-AKT on AKT and the level of MERV protein expression are lower. So AKT is lower and MERV is higher for women. Women have less protein synthesis but more breakdown. The balance between synthesis and protein breakdown tends to a greater breakdown for women with DM1. There is a potential bias because men might be stronger than women for a same age and phenotype. If men are stronger, it is a concept I explained earlier on. Maybe they have more to lose as far as muscular strength, but maybe it's related to what we are looking at in the muscle as such. We will search, and maybe we will need to correct for these factors. And there are more people of each sex to assess. We had 12 men or 12. We didn't have enough patients to be able to say that there are clearly differences. However, this is a first study that is done in DM1 in this respect. And if clinically we can see differences, now we tend to explain through fundamental analysis the reason and the relevance of this, that we are developing therapeutic trials that will develop molecules that will correct the genetic defect, and what we do to see if the therapeutic site works, we look in the patient if there's a patient. Between all this, there's the black box I was talking about. It would be important to say the therapeutic trial doesn't change the function, but oops, there were improvements there concerning the muscle histology. So maybe the therapeutic trials didn't improve. It's just maybe because If you have a 10-meter walk, yes, strength is important, but there's about balance, understanding the instruction. So looking into the muscle specifically, we are eliminating clinical variables that we have to look into. So this is why we have to go and understand this black box, quote unquote, to understand the global disease. We'll end with people. Oh, yeah. This is a fake news. This is my wish. Let's change the title. And April 25, millions for research in neuromuscular diseases in red. Just to tell you that it's a fake news. But it's a wish, it's a dream, but I think it's important together to launch that idea so that it can happen. I would like to thank my research team supporting me in my activity and also feeds that my research, my university, different granting organizations and people who allowed me to develop the project. Thanks my collaborators, students, part of the project, research professionals, and all the patients who accepted to undergo biopsies. And they call in my office to ask me when are the next sessions. Thank you. Thank you very much, Elise. You showed statistical differences. I'd like to have your opinion. Changes observed, do they have a clinical meaning when we are interested in muscular functions and strength? We see statistical differences. As a clinician, we very well see that probably doesn't have any impact on the function. The change is so small, even if there is a difference statistically, we might think that there's no impact. Can we have this same reasoning with your data? Well, it's the hen or the egg, you know, the continuum which side you read. If you read the muscle has a breakdown or alteration and how this has a clinical impact is not that clear. However, what seems the more clear is that there are clinical differences between men and women. And this is what we try to explain with the muscle. So to make sense, we have to start with clinical data to understand the muscle. It can be the other way around in physiopathology, but clinically is the best way to do it. There is always a question mark, I would say. When you go look at the muscle, what you see is real, is cash, as I said. But when we look at a functional test, there's more than the muscle ending up to the outcome or the final score. So there, the muscle will always say, yes, there is a disease, but maybe patients develop a strategy or change their lifestyle. And if we ask, do you have any problem? They will answer, no problem in my functions, but they don't do what they were doing 20 years ago. And when we ask a question, when they think about it, there's no change for them. Okay. You say that there's a higher breakdown for women, but in the graph, they seem to lose less strength. I don't know if I understand. Well, it doesn't explain. How can you explain this? Yes, excellent observation. We notice that clinically, we see that men lose more muscle strength on a 9-year period. So we see the less synthesis and more breakdown. But that's in the longitudinal study on 9 years. When we look at the histological, that it's a picture. It's if we take a biopsy on April 2nd, it's a picture of that date. It's a daily picture of the muscle. So what it says is there are more breakdown, less synthesis in women, but on 9 years, if they have less muscle than men, well, at one point, it's not like It's the chain muscular disease that will end up in a wheelchair. There's less stimulus. So these people, they will continue to walk. Men, even women, if they are not strong, they will lose a little bit of muscle, but they will preserve the muscular mass because of their function. They will not go down to zero. No, they will keep that. It's not the physiopathology of the disease to break down to zero. No. So it's a picture over time. And you see that there's a disturbance, but if you start with less muscle, the disturbance will be less than a man who has more to lose. It's speculation. We will have to need to find a protocol to answer that specific question. Thank you very much.